Hi, welcome to 2014 Paper 1, Ordinary Level, Question 4. So as always, just to say, I would suggest you take a chance to pause the video, have a go at the question, even looking at the screen, or even the strategy to do it, and then come back to me and then get it done. So question 4 here, part A. Now it's a 15C question. That's a lot for one part. This is, we're asked to solve this equation. So there is an equal. Your quadratic equation, I know it's quadratic because it has a power of 2, okay, and the equation is equal to 0. So this is actually asking me, where does this graph, now it will be a valley because it's a positive x squared, where does it cross the x-axis? That's where the equation equals 0, okay, which is basically where y equals 0. As we all know, according to geometry, y equals 0 at the x-axis. So let's go ahead and solve it, okay? Now, if it's just the fast way, I'm looking at opening up two brackets, okay? Put x in the first bracket, x in the second bracket. Now, I've looked at this question before. It will solve using the fast method. I'm looking for what numbers will multiply to give minus 6 and add to give minus 1, okay? Now, if you look at it, if you think about it, minus 6 by plus 1 won't work. Minus 3 by minus 2 will give plus 6. Minus 3 by plus 2, okay, will give minus 6. When they add them, minus 3 plus 2 will add to give minus 1. So the numbers minus 3 and 2 satisfy my equation. Now remember, that equation is equal to 0, okay? So the values of, they're the factors, but the values of the factors are x minus 3 equals 0. Okay, therefore x is equal to plus 3. Okay, so same thing, x plus 2 equals 0, therefore x is equal to minus 2. So I've located the 2 points, okay, minus 2, plus 3, where the curve cuts the y-axis, okay, cuts where y equals 0. Now move on. That's the answer done the fast method, just for practice. I've done the question out using the quadratic formula. Okay, so I've also done it out using the quadratic formula, and I've identified the parts of the quadratic that are important for that formula. This is the number in front of the x squared, is a, number in front of the x, in this case it's minus 1, but that's the b, and the number at the end, which is the c value. So once I have a, b, and c, I can put them into the formula, which I've done here. Then go left to right, remove brackets, end up with this statement here. Okay, plus 1 plus or minus the square root of 25 over 2. Now, I can split that square root of 25 to get 5 and just finish it off, and I get my answers x equal to 3 or x equal to minus 2. The longer but equally valid method. So that's part A. Now, part B here gives us 4 graphs. Okay, you have to recognize which one of these graphs is of the function in part A. So, which of the graphs above is that of the function f of x is equal to x squared minus x minus 6. Now, it's just weird function notation. They could have used f of x, okay, or they could have used y, okay. It's just, you know, one of the types of notation for this type of maths. And let's exclude ones we can, okay. Now we know the value of the factors is minus 2 plus 3. So straight away, well, graph A is out. Okay, now the graph will be a valley, okay, because it's a positive x squared, but its factors are different. Now again, okay, it can't be b because it's the wrong, it's a mountain, not a valley, but it also can't be because the factors are wrong. So A is gone and B is gone. Now it's between C and D. Now if I look at it, okay, the factors here are right, minus 2 plus 3, but this is the graph of a minus x squared. Now you do need to kind of know, well not kind of, you need to know that, okay, that's supposed to be a 2. This is a positive x squared. So the right factors is the graph of a positive x squared. All the others are excluded due to reasons, so the graph has to be D. Okay, so move on. Graph D. Okay. Now part C is tricky, so it's going to take a bit of time. The graph of the g function x squared minus 2x is shown below. Okay. X is an element of order, this means it's any number. On the same diagram, sketch the graph of each of the functions. Okay, now we give you this part 1 as a h function, and it says it's the g of x function plus 2. I'm going to flick the answer in the next page so I've done it digitally and be clearer. And the answer is built in there. Okay, so I see the h of x function there. Now I've solved it here. I've got the g function plus 2. The g function is here. So I'm adding 2 to that function to get the h function. I've done that here. Now if you use the quadratic formula, I didn't do it here because I don't have a space of it, and I've just kind of done it on the last page. But it's the same thing. X is, a is equal to 1, b is equal to minus 2, c is equal to 2. That's applied to the formula. You're going to get a negative number under the square root, okay, and you're going to find the two complex solutions. Okay. Now, if you graph a complex quadratic, it'll never touch the y-axis, so the x-axis, okay, where y is 0. Okay, there's no real solution. Now, the complex number 1 plus I, now, this is an x and a y-axis, but it correlates to an Argand diagram. So the real part is 1, the imaginary part is 1. Okay, so that's the minimum point of your graph. Okay, and it follows the same basic curvature. Okay, now k function, I've done it here, it's g of x plus 2. So I'm putting x plus 2 in instead of x in the g function. Okay, remember the g function was the one you were given here. So I've done it down here, okay, and it's a bit complicated to have to work out x plus 2 squared, but I've done that here in rough work. Brought the answer back in, combine the x's, combine the numbers, and I end up with the function x squared plus 2x. That's similar to the g function, but it is different. I'm factorizing this by putting a variable out, x, out of both terms. So your x squared plus 2x is the same thing as x times x plus 2. Now there's two factors there, okay, so x will be equal to 0, and x plus 2 equals 0, therefore the value of the factor is x is equal to minus 2. And that gives me the 2 points here, minus 2 and 0, and the graph follows the same curvature. Okay, now that's tricky, okay, so there's the last point here over here, this section here, where we've actually found the minimum point using differentiation, okay, and it works just the same, okay. So there's multiple ways to do this question. It's not normal, okay, and you're sketching graphs, and you have to, familiarity with quadratics has to be fairly good to be successful in this question. Thank you, and have a good evening.